This tutorial shows how to calculate Cohen's d as an effect size in the case of an interaction effect in a two-way ANOVA in SPSS. First, note that we are now dealing with pairwise comparisons, i.e. whether income differences exist across genders for each experience level or across experience levels within each gender. For the pairwise comparisons that showed a sufficiently small p-value, an effect size should be calculated. Since these are pairwise comparisons, we use Cohen's d. I will now demonstrate how to calculate it. All that's needed is to run independent samples t-tests. However, this requires setting filters and/or using split file output. I will demonstrate this with my example, where an interaction effect with a sufficiently small p-value was observed. Gender has 2 levels and experience has 4 levels, as shown in the pairwise comparisons. I observed differences between men and women on experience levels 1, 2 and 4. Accordingly, I need 3 independent t-tests on experience levels 1, 2 and 4, comparing men and women. Since gender has only 2 levels, the t-test only needs to be set up once. The t-test will then be applied to all levels of the other factor, here experience, which is achieved using the split file function. In SPSS, this is done via data, split file. On the right side, select the third option, groups based on. The grouping is based on the variable experience in this case. Then, the independent samples t-test is carried out via analyze, compare means and proportions, independent samples t-test. The test variable remains the same as in the ANOVA. Next, the grouping variable must be defined, in this case, gender. Click on Define Groups and specify the values for the groups. In my case, 1 stands for men and 2 for women, which is already preset. You can now run the analysis and get a separate t-test for each experience level, 4 in total since there are 4 levels. For experience level 1, we see a mean difference of 448.12, which matches the result from the ANOVA pairwise comparisons. Cohen's d is shown in the third table under the column Point Estimate. We can see a d of 0.607 for the gender difference on experience level 1. The calculated effect size should ideally be interpreted based on comparable studies. If such studies don't exist, use research field specific thresholds. As a fallback, Cohen 92, a power primer, provides useful thresholds on page 157, which are widely accepted in social and behavioral sciences. 0.2, 0.5 and 0.8 for small, medium and large effects. For pairwise comparisons with no sufficiently small p-value, such as experience level 3 in my case, a d value can still be reported for completeness. Now that we've calculated effect sizes for gender differences across experience levels, let's examine the differences between experience levels within each gender. To do this, we must adjust the split file setting. Go to Data, Split File, and this time base the grouping on gender instead of experience. Now, run the independent samples t-test again through Analyze, Compare Means, Independent Samples t-test. The test variable remains the same, but the grouping variable changes, this time from gender to experience. Unfortunately, this part is a bit more tedious, because each pairwise comparison must be defined manually via define groups. So first compare experience levels 1 and 2, then 1 and 3, then 1 and 4, and so on. With 4 experience levels, this results in 6 comparisons per gender, though the actual number may be lower depending on the p-values. In general, for n levels, the maximum number of comparisons is n times n-1 divided by 2. The process should now be sufficiently clear. When an interaction effect exists, it takes priority in interpretation. Depending on the type of interaction, see the linked video, main effects can also be meaningfully interpreted. The next video will show how to calculate effect sizes for those cases.